Welcome back, everyone. Here we are where we left off last time. Previously, we have a very simple autoencoder that takes the original image, reduces it down by 97%, so from 784 dimensions down to 25, and then expands it back out and attempts to reconstruct it. And we saw the results here. Next, let's go ahead and apply this for an application of denoising images. To begin, we have to first figure out how we're actually going to add noise to our images. Lots of different ways you can do this, but for convenience, we're actually going to make it part of the autoencoder by saying from TensorFlow.keras.layers import Gaussian noise. And what I'm going to do is just show you a sample of what this actually does by saying Gaussian noise. And you'll notice that it just takes in a standard deviation. Obviously, the larger value you choose, the more noise is going to be added. And then let's grab some of those noisy images. We'll say noisy is equal to sample. And let's go ahead and just say xtest. Let's say grab the first 10 images as a batch. And to make sure this actually trains and adds noise, I just need to say training is equal to true there. When you run this, you may get a warning such as this. This is just a data type warning due to TensorFlow 2, but since we're actually running TensorFlow 2, we can ignore this warning. Okay. So I have these noisy images. Let's go ahead and see what they look like. I'm going to just say n is equal to 0, and then let's print out original and say plt imshow from our xtest set n, and then then say here plt show, and then after that we'll say plt imshow from noisy. Go ahead and grab n and say plt show. And right before that, we'll go ahead and print out noise version. So run that, and you should see the original 7. Here's what it looks like. And then after being passed in through that Gaussian noise layer, here we can see that noisy version. So clearly, there's a lot of noise here that our autoencoder will hopefully be able to remove. So let's create the noise removal autoencoder. To do this, I'm just going to do a quick import here of import TensorFlow as TF. And then what I'll do is I'm actually going to use the same encoder and decoder as before, just add in that noise layer. So we'll come back up here, and in the previous lecture we created this encoder. Go ahead and just copy it, scroll all the way back down here, and then paste it in. And what we're going to do is after we've flattened this out, but before we reduce the dimensions, we're going to say encoder, and we're going to add in that Gaussian noise layer. Let's go ahead and add it in of 0.2. Obviously, this is something you can play around with. And then in order to make sure the same noise that you create was what I create, let's go ahead and set a random seed. We can say tf random set seed. And this is the same thing as if we were to set the random seed of numpy by saying np.random.seed as 101. Recall 101 is just an arbitrary number. So there's our encoder, exactly the same as before, except right after flattening it, and before reducing any of the dimensionality from it, we added in this noise. So go ahead and run that, and then let's grab our decoder. So we'll come back up here, and the decoder half of things is actually exactly the same. So we just need to copy this, scroll all the way back down, and go ahead and paste it in. Okay, so we have our encoder and decoder. Let's combine them to create our noise remover. We'll say noise remover is equal to sequential, and then combine the encoder with the decoder. And then let's compile this by saying noise remover compile, and same loss as before. So we'll say binary cross entropy. And for the optimizer, you can play around with stochastic gradient descent if you want. We'll go ahead and just kind of keep things simple now, just pass an atom. And let's go ahead and keep track of our metrics. Let's go ahead and just also keep track of accuracy. So compile your model, and then we will fit our model. We'll say noise remover fit, and we pass in the X training, and we also want to compare it to the same original images. So X train, and then train it for some amount of epochs. Let's go ahead and choose 8. If you want, you can pass in validation data in order to compare it to see how it's actually removing noise from test images that it hasn't been training on, but we'll go ahead and just run it as so. Okay, So here we are going to train it for 8 epochs. Let's go ahead and fast forward in time until this is done training. All right, now that this is done training, let's go ahead and pass in some noisy images through this noise remover autoencoder and see how it actually performs. To do this, I'm going to create 10 new noise images. We'll say 10 noisy images. And I'm going to pass that through the original sample that we saw before, which is just the pure Gaussian noise. Let's go ahead and take xtest, pass in, let's say, the first 10 points, and then say training is equal to true. And so here we have our 10 noisy images. And then what we're going to do is pass those noisy images through the noise remover autoencoder. So we'll say denoised, so to speak, or removal of noise is equal to noise remover. And we're just going to pass in those 10 noisy images. There we go. And then let's go ahead and print out 3 things. We're going to print out the original image. So what it looked like before you even put noise on it. So original image. And then we're going to print out the noise added image. And then finally, we're going to print out what it looks like after noise removal from autoencoder. Okay, so what does it actually look like? Just as we did before, let's go ahead and just choose n so you can play around with this from that batch of 10 points. We'll say plt im show. First, grab from the original xtest dataset, one of these, and then say plt show. And then let's go ahead and copy these lines. Except now for noise added image, that's going to be from 10 noisy images. And then after noise removal from autoencoder, that's from this denoised, so to speak. So we'll say denoised. And something to keep in mind here is that the way we actually design this autoencoder, the encoder part is actually going to add noise again. So this is kind of like double noisy images that are being encoded in and then decoded out. So just keep that in mind that this is almost like twice the amount of noise. So let's go ahead and run this and see how well our autoencoder actually performs. So here's the original image, the first one. So there's a 7. This is what it looks like after one noise pass. And then after going through the autoencoder, where we first add more noise to it, then compress it down, so to speak, or reduce the dimensionality. And then after we expand it back out, it looks like this. So clearly it was able to remove the noise. So the autoencoder then actually learned what pixels were important in being able to recreate the image as output. And so you can play around with this again, maybe choose another image from that batch, such as this 0. Here's the noisy 0. And then here it is after the noise removal. Okay, so really cool applications we can use for our autoencoder. Coming up next, we're going to set you loose on an exercise that focuses on using dimensionality reduction in order to figure out the hidden insights in your real data set. I'll see you there.